Algebra 1, Chapter 11, Section 3, Simplifying Rational Expressions. So what is a rational expression? In this case, we are talking about an algebraic fraction whose numerator and denominators are polynomials. The lesson menu tells us we have 6 examples to hop on through. So what is the excluded value for this function? So that's when we find what x equals and y equals. So our excluded was just the denominator. So we said x minus 4 equals 0. We get x equals 4 when we solve. So we get D. Excluded function. So again, 2x plus 4 equals 0. We subtract 4 from both sides. 2x equals negative 4. We divide by 2 on both sides, and x equals negative 2. What are the asymptotes? We need x and y. So x plus 6 equals 0 gives us x equals negative 6. And we have y is equal to 0 because there's nothing added on out here. So right here, and they give us an idea of what it looks like. So it said to graph, and they didn't give us a graph for any of the other ones, so yeah, it kind of has to be that one, doesn't it? An x of negative 6 for an asymptote is this one right here. Y is equal to 0. You can always do values for x and y. Since we know that our horizontal asymptote is 0, and our y and our vertical is negative 6, so we could do, negative 7, negative 8. You could do negative 5, negative 4. Those would be perfectly good x's to use. Graph this after you find the asymptotes. So x plus 1 equals 0 for our vertical asymptote. So x equals negative 1. We have a horizontal asymptote when y is equal to whatever's added or subtracted. So in this case, negative 2. So y is at negative 2. Looks like this is going by 2's. Okay, we're going to skip this one, mainly because I've been looking some stuff up and I'm not finding what I want because it's all in calculus instead of in algebra. And so why they got negative 1, I honestly can't tell you why at this point. I'm going to do some more research on it, and if I come up with something that's not calculus, I will get back to this and redo this video. Until then, moving on. Let's see what they decide to do. What are the asymptotes? Well, it should be x at negative 4 and y at negative 5, so this one treats me nicely. I'm assuming the reason that this is a y of negative 1 is something to do with the fact that we have the x minus 3 out here, but I'm not completely certain. Again, I can do it in calculus, not so much there. What we have done is simplified expressions involving the quotient of monomials, and we have identified values we are going to identify values excluded from the domain of a rational expression and simplify rational expressions. Rational expressions or CAB. State the excluded value. So that's when the denominator is equal to 0. So b is equal to negative 7. So subtract 7 from your side. So the answer B cannot be equal to negative 7, so it must be excluded here, just like we did before. And now we get to see a little more complex. So we have 5a squared plus 2 on top in our numerator, a squared minus a minus 12 in our numerator. So again, state the excluded value. The first thing we have to do is use those factoring skills that we learned in the previous chapter. And you can do the window. Some of these you're going to know, so they can break it down. Remember, with the window, I'll do one here, a squared and 12, 1 and 12, 2 and 6, 3 and 4. We need one of those that makes that negative 1 in the middle. It'll be this one right here. So we have a minus 4, a plus 3. We set each one of those equal to 0. So we get that our excluded values are when a is equal to negative 3 and when a is equal to 4. Again, stating the excluded value, so 2x plus 1 equals to 0. Solve for x. Our excluded value is negative 1/2. State the excluded value here. Y plus 3 equals to 0. Solving for y, you get negative 3. let's see, factors of 6, and you can make with 2 negatives gives you a -5, but a +6, so this doesn't work. A -6 and a +1. Oh wait, we want a +6, so -2 and -3 is what we want. So x minus 2, x minus 3, set them each equal to 0, so we get x equals 2 and x equals 3. Again, find the excluded value. Subtract 2, solving for that x. 5 and 3, so x equals -2/3. The height of a cylinder with volume V and a radius R is given by the equation V over pi r squared. Find the height of a cylinder that has a volume of 770 cubic inches and a diameter of 12 inches. So first things we need to realize is that volume equals 770. Diameter equals 12. We don't need diameter, we need radius. So that's half the diameter, which is 6. So we substitute all of that stuff into our equation. We solve down and we get 6.8. So the height of the cylinder is approximately 6.8 inches. You can use estimation to determine whether the answer is reasonable by putting 7 in. 800 divided by 3 times 36 is 7. Works out. Find the height of a cylinder. So again, height is equal to volume divided by pi r squared. That has a volume of 680, a radius of 8 inches, round to the nearest tenth, so height of 680 divided by pi times 8 times 8 is 64. So I'm going to take 680, I'm going to divide by pi times 64, parentheses, and now I get an h is equal to 3.38 or 3.4 rounded to the nearest 10 inches. Our first key concept here is, so let A, B, and C be polynomials with A not equal to 0 and C not equal to 0. So we can say that B times A over C times A, well, they both have an A in common, so we can cancel out the A, so that's equal to B over C. So all it's saying is, you can simplify rational expressions by taking out what they have in common. Even if what they have in common is large and in parentheses, okay? And is a binomial, you can take it out. It can be a trinomial, whatever, but you can get rid of it and simplify. So which expression is equivalent here? So what can we take out? Well, we have a 4 in common. We have 1 x in common, which leaves me with 4 on top. We have 2 y's in common, which leaves me with 5 on bottom. So that's 8x to the 4th over y to the 5th. 8x to the 4th over y to the 5th. So the answer is B. They took out what they had in common by breaking it up. That's fine, but I don't think we need to see it on that one. We'll see different examples of that here in a minute where we'll be using our factoring abilities. What do we have in common? Well, I know that 60 is not divisible by 18, but I know they're both divisible by 2. And I know that both of these are divisible by 3. And they can't be divided anymore. I have 1a in common, which leaves me with 2 a's on top. 2 b's in common, which leaves me with 1 b on bottom. So that's 10 a to the 2nd over 3b, which is c. Simplify here. So here's the fun stuff. This is where we get to factor stuff down. We take out what we have in common. So on this top one, we have a 4 in common, which leaves us with 4 times the quantity x plus 4. And if we use the window on x squared, we see that we have x minus 9 and x plus 4. So remember, you're taking those factors of 36, so 1 and 36, 2 and 18. Remember, it's 1 times 36. That's how we got the 36. 3 and 12, 4 and 9, 5, 6 and 6. We need to make a -5. So this one's in, out, out, out. -5. So there you go. X minus 9, x plus 4. We take out what we have in common, and you're left with 4 over x minus 9. kind of fun. Let's see. Then exclude the values for this function, this rational function. So we take whatever's on bottom, set it equal to 0. Let's see. So exclude the values for which x squared minus 5x minus 36 equals 0. So we take the bottom that we factored before we started taking stuff out. We set them equal to 0. So x is equal to 9 or x is equal to negative 4 are what we're going to exclude. So our simplified rational expressions, we simplified it to 4 over x minus 9, and then we also found the excluded values. So let's simplify here. So we can take out 5, w minus 2 over the negative 16. So 16 times that 1, so factors of 16. 8, 3, no, 4, and 4. We need to make a 6. Only one way. It needs to be a positive 6. So then this will be w minus 8 plus 8 and w minus 2. Those cross out. We're left with a 75 over w plus 8. Then we take that w plus 8, set it equal to 0, and that w minus 2, set it equal to 0. So we get w equals negative 8 and w equals 2. Simplify and state the excluded values. So again, we first factor, in this case we're factoring the top, 5 minus x and 5 plus x over, take out an 8, you're left with x minus 5, so you notice none of those match up. But what you can do is you can take a negative out. We could have done this from the beginning, taken a negative out here, and we would have had x squared minus 25, so that you have x minus 5 times x plus 5. Which is the same thing as you see here. Remember, they're both positive, so you can just switch them around pretty easy. Let's see, so then we come down to negative 5 plus x over 8. We do need to find that excluded value, so we take x minus 5 and 8 both, set them equal to 0. 8 cannot equal 0, so it's not 1. X minus 5. Solve, and you get x equals 5, so that's our excluded value. What they did here is they just took what was on the bottom. They didn't even factor it because we didn't have an x squared. We just had a linear value on the bottom with an x to the first power, and we could just solve for x. You can tell either way, you get the same answer. Simplifying. So this, I'm going to go ahead and make it negative. And so that we have negative x squared minus 49. So this is one of those special cases, so I know I can do x minus 7 minus x plus 7. Obviously, you can't always go ahead and do the window. And then I can take out 5, and I'm left with x minus 7. So now I have negative x plus 7 over 5. So negative x plus 7 over, wait, sorry, there we go. They did 7 plus x, which is fine. And then we take what's on the bottom, so 5 equals to 0, doesn't happen. X minus 7 equals to 0, so x equals 7. Find the zeros. So find the zeros. So once again, we are simplifying. Then we set whatever's on the bottom equal to 0, and we're going to get our 0 of the rational function. So when x equals negative 7, the numerator becomes 0, so f of x equals 0. So therefore, the 0 in the function is negative 7. So we factor. This factors of 20, 1 and 20, 2 and 10, 4 and 5. The only ones there that can make a negative x and is right here. So we have x plus 4, x minus 5 over x plus 4. So we have x minus 5. We find the zeros of this. So just like in our example, we take that x minus 5 and set it equal to 0, and we get x equals 5.